I would love to give a huge thanks to Atrium and the Uniswap Foundation for making this incubator a possibility. I really enjoyed playing around with bleeding edge tech during my time at the incubator. I'm Huang Isaac, a smart contract slash security engineer from NYC. I spent most of this year auditing cross-chain protocols and learning how to deploy an AVS on EigenLayer. For this incubator, I focused on learning how hooks interact with external methods or other protocol smart contracts. Just like Sanctum achieved 700 million plus TVL on Solana, we're targeting Ethereum's massive $57 billion staking market, where the infrastructure is desperately needed. Let me quickly paint the picture. 27% of all ETH is staked. Over 40% of that is in LSTs. But unlike Solana, Ethereum lacks a unified LST infrastructure. This leads to fragmented liquidity and high friction. The problem? Converting and staking LSTs require multiple complex transactions, creating high barriers for users and protocols alike. UniStake solves this by providing one transaction conversion and staking, native EigenLayer integration, and cross-chain staking capabilities through Chainlink's CCIP. Technical overview. The router's swap method will enable interaction with users on the front-end side. The router is set up to specifically work with our hooks pool manager, which charges swap fees and enables swaps between ETH/LSTs across chain. So our swap method converts ETH to LST and triggers deposit logic, and our deposit LST into strategy method manages deposits into EigenLayer and tracks users' position. For the demo, I will showcase how UniStake's router interacts with UniStake's cross-chain staking hook. Let's run our unit test to display UniStake's capabilities. Our first test highlights our user swapping ETH for LST. So a user sends 0.1 ETH, our router manages the Uniswap v4 swap, then the hook processes the completion of the swap. Finally, the user receives their token. Now, we're direct staking into EigenLayer. So the user will swap ETH for LST, then directly stake the LST into EigenLayer. So from reading these logs, we can notice how the swap executes and tokens are immediately staked. So our user can swap ETH for LST, then opt into restaking LST, or in other words, deposit LST into EigenLayer. Finally, our user can swap ETH for LST and stake across chain after swap. Let's run this test and see it in action. So for our last unit test, you can notice how the swap executes and CCIP handles the bridge. Then the token arrives on the destination chain. Phase one of the implementation roadmap is complete. We plan on bringing a multi-LST infrastructure to Ethereum's $57 billion market. We're targeting protocols building on EigenLayer, LST providers, and institutional stakers. Our architecture is currently made up of multiple components, which include Uniswap v4, EigenLayer's core contracts, and Chainlink's CCIP.